This is a tutorial on creating and recoding variables in SDA. For the sake of illustration, we will use ICPSR study number 4549, the 500 Family Study Parent Data, dataset number 3. I have already logged in to my MyData account. However, this study is a part of the Research Connections archive and can be accessed without authentication through their website at www.researchconnections.org. But we will continue through the ICPSR website. On the study's homepage, scroll down to DS3 Parent Data and look for Analyze Online. Click on SDA. This takes us to the terms of use on the Research Connections website. We must accept the terms before we can access the data. In this tutorial, we will refer to information on the variables that is displayed by clicking the View button when a variable is in the variable selector. However, the codebook is available if you would rather use it. Go to the menu at the top of the SDA window and click on Codebook. The full codebook is available under the full documentation link. The research question asks, are a worker's perception of his or her job affected by irregular work hours? To answer the question, we will create a scale from the variables work exhaust 1, work anger 1, work drain 1, work stress 1, and work bore 1. We'll name it job at. The variable will be created by averaging the responses to these questions and defining the high score, 5, as very negative, and the low score, 0, as very positive. We will enable decimal places to capture the range of responses as we're averaging the 5 variables. This scale works because all the responses to the variables are coded in the same manner and all questions ask about the same type of thing, the respondent's opinion of their job. We will also recode the variable job hours 1 into a dummy variable. Presently, the variable describes the type of shift that a respondent works. We will recode this variable so that it answers the question, do you work an irregular shift? The responses will be coded as 0 equals no for those who work a regular shift and 1 equals yes for those who work an irregular shift. We will name the new variable irregular shift. Then we'll run a cross-tabulation using these new variables. To create the new variable, select the Create Variables menu at the top of the SDA window. We will use the Compute option to create the new scale variable and the Recode option to create the new dummy variable. Click on Compute a new variable. The SDA window has the familiar variable tree and variable selector on the left-hand side, but now it has the Compute program on the right. This program will let us name a new variable, select the input variables and values, and specify the output variables and values and their labels. Also, we can define missing data and write a short description of the new variable. And there's a link to helps with writing syntax for SDA and one for general helps with SDA. We start in the expressions window by naming the new variable, job at, and add an equal sign and an open parentheses. Now we move to the variable tree and select the variables to create the scale. Look for work exhaust 1 and click on it to move it into the variable selector, then click on the Expressions button to move it into the Compute program. Add a plus sign and return to the variable tree. Click on the next variable, work anger 1, which moves it into the variable selector, and then click on the Expressions button to move it into the program. We'll repeat this process until all 5 variables are in the Expressions window. When the last variable, work bore 1, is in place, we'll add a closed parentheses and a /5, as we want to divide the sum of these 5 numbers by 5. You can also use the sum function for the addition step, but it will not include the missing values. Look at rounding a new variable. To add decimal places, let's add 2 decimal places. Let's add a label to the variable, respondent's attitude about job, and we'll code the missing data 999. We can add 0 as the minimum value and 5 as the maximum value. A bit of descriptive text can be added here if you wish. We'll also add labels to the values using the category label feature. The variable has a range of 0 to 5. We'll label the low and high ends only. Let's name the high score 5, very negative, and the low score 0, very positive. Clicking on the Start Computing button runs the syntax. The results begin with a confirmation of the program and study used. It confirms the new variable and the 5 variables used to create it. That's followed by the syntax, as it was written in the expressions window. This variable can be found in the list created variables and will reside there for about 30 days. Let's recode the variable job hours 1 into a dummy variable. We'll start in the Recode program. In the variable tree, search for the variable job hours 1 and click on it to move it into the variable selector. This program will let us recode up to 6 variables, but we are only using 1, so click on var1 to move the variable into the Recode program as var1. Go to the top of the program window and name the new variable, irregular shift. In the Recoding Rules section, we will specify the new values, labels, and the corresponding values from the input variable job hours 1. We'll code the new value 0 as no and the value 1 as yes. As job hours 1 is still in the variable selector, let's click on the View button to see the value labels. See that the values 1, 2, and 3 specify regular shifts, so we'll code these values 0 for no. Back at the Recode rules, in the cell for 0, under var1, we'll put 1, 2, 3. Return to the frequencies for job hours 1, we see that the values 4, 5, 6, and 7 are irregular shifts, which we will code 1 for yes. At the Recode rules, we'll add these values to the cell for 1 under var1. Let's add a label. Do you work in a regular shift? And add 999 to the missing data code. We won't define the minimum and maximum for this variable. Click on the Start Recoding button to create the variable. The results begin with the confirmation of the program and study used. We have used the Recode program to create the new variable irregular shift using the existing variable job hours 1. It shows how we have coded the new variable and what the frequencies for the new variable are. Like the other variable that we created, this one will also reside in the list created variables for about 30 days. Now let's create a crosstab with these 2 new variables. Go back to the main SDA window and click on the Analysis menu and click on Run Frequencies and Crosstabs. This retains the variable tree and variable selector, but changes the program on the right-hand side to frequencies and crosstabulations. We can't use the variable tree to select variables for this crosstab because the new variables are in the list created variables. Go to the Create Variable menu at the top of the SDA window and click on List Created Variables. To move the variables into the variable selector, click on the name, Job At, and then click on Row to move it into the row position in the program. Go back to the List Created Variables and repeat the process. Click on Irregular Shift to move it into the selector, and then click on COL to move it into the column position. We don't need to add anything else to this analysis, and all the table options are OK, but let's change the type of chart to bar chart. Click on Run the Table. This will launch a new window with a confirmation of what we have done. We have created a table with job at on the row and irregular shift on the column. That's followed by the frequency distribution and then the bar chart. This table and chart are a little hard to read, but SDA gives us a couple of options to fix that. We could go back to the Recode program in the Create Variables menu and group job at's values into fewer categories. But let's use the temporary Recode command in the Crosstab program. We'll add labels to the values for the range of negative to positive responses about the worker's perception of his or her job. Go back to the cross-tabulation program with the variables in place. To temporarily recode job at, we review the frequencies as we did earlier when creating the new variable irregular shift. That's already been done here, and we're just going to enter the new coding scheme into the row position in the Crosstab program. We put our cursor in the row line next to job at, add a space, and type open parentheses R:, followed by the values to be recoded, such as 0, space, open quote, very positive, close quote, semicolon. The temporary value labels are enclosed in quotation marks and follow the existing values to be recoded. A semicolon separates one new value from the next. If a range of values is collapsed, those numbers are separated with a hyphen, such as 0.2 hyphen 1.2 space, quotation mark, positive, close quotation, semicolon. When the coding is done, add a close parentheses. There are other ways to temporarily recode variables described in the Recode Variable Helps at the top of the Frequency and Crosstab program. We don't need to change anything else here, so we can click Run the Table. The new window is launched and confirms that the results are based on the temporarily recoded variable job at on the row and irregular shift on the column. The confirmation of the temporary code for job at can be found under the chart. If you wish to change it, you can go back to the cross-tabulation program, make the adjustments, and rerun the table. However, SDA does not save temporary recodes. When we're done with this analysis and move on to a new program, or if we clear the fields in this program, the temporary recode is deleted. Our research question asks, are a worker's perception of his or her job affected by irregular work hours? The answer seems to be no. An irregular work schedule does not affect the worker's perception of their job. This has been a tutorial on creating and recoding variables in SDA.